Okay, now in this video, we're going to differentiate the following functions using the chain rule. Good. So we had the first one to be y equals the cosine of 2x, and then the second one is 1 over the square root of 4 minus x, and then lastly, sine to the third power of x. Good. Anyway, even without telling you where to use the chain rule to differentiate each of these, just looking at the structure of the function, this is cosine of something, and that thing is not just a single term, right? Just like when we have cosine of x or cosine theta, that is just cosine of a single thing. In this place, that single thing has been replaced with 2x, right? So this is now becoming a function of another function, right? So whenever we have y to be a function of a function, then we can apply the chain rule. Good. So we're given the first one. What to differentiate this, I'll first of all make sure that this inside here is only one thing, all right? So I'm going to do a substitution. I'm going to start by saying maybe I can bring in anything. Let's say we call it u, right? Be the inside. So you want to replace these two things with just one thing. For example, in terms of cosine theta, right? But I'm going to use u. So let u be that 2x. Okay? So that means that we are going to have y is cosine of 2x, where 2x is now u. So we're going to have cosine of u. Good. And now, when we make the substitution, right, and using the substitution, we rewrite the function, we are going to have to differentiate each of these, right? So I'm going to differentiate u with respect to x, and I'm going to differentiate y with respect to u. Good. So I'm going to put it down like this. Du dx will be, well, since this is u equals to 2x, du dx will just be the derivative of 2x, right? Which is just 2. Good. And then we are going to differentiate y with respect to x. So I put it down there, the y, the x will be, well, cosine of u. When we differentiate the cosine of something, we have negative sign of that thing, right? So negative sine of u. Good. And now we've gotten the derivative of the y with respect to u. Oh god, this is the derivative of y with respect to u, not with respect to x. And then the derivative of u with respect to x. We can now apply the chain rule, which tells us that the y dx will become the y du times, right, du dx. And if you visualize this set of fractions, dy dx is dy du is dy du, right, times du dx. So if you visualize these two fractions, you see, since this is a multiplication, this denominator and this numerator are the same. If we kind of cancel them, all right, we will get back dy dx. Good. But we are not just going to cancel it, so we are going to substitute this term and this term and multiply them together. That will give us the result. Okay, so we have the y du to be negative sine u, right? So you put it down there, negative sine of u, and then we multiply it with du dx is given to be just 2, right? So you multiply it with 2. Well, all in all, we're going to enter with these two. I'll multiply it to negative sine x at once, so we're going to have negative 2 sine, okay, sine u. So you don't multiply the 2 with this angle, right? That's why I'm putting in a bracket. You don't touch it. Great. And now, lastly, we are going to have to make a backward substitution. We have here to be u. We want it to be in terms of x. Remember, the function was given in terms of x. So the result or the derivative should also be in terms of x. So here we are having a u, and u is the same thing as 2x. So in place of u, I'm going to put down 2x, all right? So in place of u, I'll just put there 2x. Good. And this right here is the derivative of the function y with respect to x. Great. Good. And now, looking at this, okay, this set of steps, we can just look at this as this one times this one. Now look, this is cosine of 2x, right? When we differentiate that, we have to differentiate the cosine first, cosine of something first. And what we have, when we differentiate that, we have negative sine of that thing, and then we multiply it with the derivative of this inside, which is 2x, the derivative of 2x, which is just 2. So I did mean we didn't make all the substitution. We started with, we differentiate the outside and keep 2x without touching it, and then multiply it with, go inside and differentiate. We will still get what we want, all right? Let's look at this using the second example. So we have the second one to be y is 1 over the square root of 4 minus x. Well, first, I'm going to have to rewrite this function, okay, I'm going to write it so that it looks like a power function. So we're going to have y to be, well, since this is 1 over something, all right, that means this thing will now have a negative exponent. So let me put it down here, square root of 4 minus x raised to power negative 1. This takes care of that fraction, all right, to give us 1 over that. So you know when we have a negative exponent, this thing will go down, as in this case. Great. And now, since this is square root, it is the same thing as raised to power 1/2, right? So we're going to have 4 minus x raised to power 1/2, and then we raise it to power negative 1. So this is 4 minus x raised to power 1/2, that is the square root of 4 minus x, and then we raise it to power negative 1, all right, which is just here. Good. So from here, maybe we can multiply the exponent just by exponent rules. When we multiply the exponent, that is negative 1 and negative 1/2, we're going to have negative 1 and 1/2, we're going to have negative 1/2. Great. From here, we can now differentiate this function with respect to x. Okay, so let's see how we can do it without making some set of substitutions. So we have dy du, okay, dy dx to be, all right, good. Let's start with the function itself. We have, assuming this is, we make a substitution, all right, we will call this place u, all right? So we are going to be having, let me just put it down here for you. We're going to be having y equals to u raised to power negative 1/2, right? Let's say u is 4 minus x. So we're going to differentiate y with respect to x. That means we're going to have to put this to the front. That will become negative 1/2. Then we multiply with this thing and subtract 1 from the power, right? Just by applying the power rule, we have negative 1/2 multiplied with 4 minus x. Multiply with 4 minus x. And then we subtract 1 from this power, right? Subtract 1 from it. So we've differentiated the outside function. We haven't touched the inside. What we have to do now is to multiply it with the derivative of this inside, all right? So in this case, the inside is just 4 minus x. So the derivative of 4 minus x, when you check that out, it is just negative 1. So we multiply that with negative 1. Good. So if you check everything together, we are going to have, let me simplify things a little bit for you. Negative 1/2 times 4 minus x. Now this power will give us negative 3/2, right? Times negative 1. Okay, great. And now we multiply this negative 1 with this negative 1/2. We're going to have positive of that. So this will become 1 over 2 times the square root of 4 minus x. Then we raise that to power 3. Good. Okay, that is just by 1 over 2. Then the negative and the negative 1, they multiply and become positive, all right? And then we have the square root. Because of this negative exponent, this will come down. And then the fraction that tells us power 3 and then root 2. Good. Okay, so this right here is the derivative of that function with respect to x. Okay, all right. Let's go ahead and look at the third one. Okay, here we have y to be sine of to the third power of x, all right? Well, this is the same thing as sine x raised to power 3. Good. So whenever we have sine, then you cube first before you write the angle. It's the same thing as this, right? It's just the matter of convention. Okay, so that means we are going to enter with y is sine x, then raised to power 3. Good. So to differentiate y with respect to x, we're going to have the y, the x, to be, Now let's figure this sine x as the inside function, right? Something raised to power 3. If you want to differentiate x raised to power 3, you bring the 3 to the front, so it becomes 3, and then you multiply it with that thing, all right? So in this case, that thing is just sine x. And then you raise it to the power minus 1, that is 3 minus 1. That's just by looking at this as a single variable. Okay, you use a power rule, bring the 3 to the front, write that thing, then subtract 1 from that power. But since this inside is not just a single variable, it is a function of x, okay, we need to multiply it with the derivative of the inside. So the derivative of sine x is now cosine of x. Alright? And then all in all, we're going to enter with, well, 3 times sine x, right, raised to the power 3 minus 1 is just 2. So I can put it down as sine x raised to the power 2. And then I multiply it with the cosine of x. Great. Now notice that we had sine cube x, we put it down as sine x all raised to the power 3, right? It's the same thing. So here I'm going to rewrite sine x all raised to the power 2 as sine squared of x, right? So maybe let me make you see the solution we're having right here. This is just 3, then sine to the second power of x times the cosine of x. And that right there is the derivative of that given function. Alright, great. Okay. Thanks for watching. Please subscribe to my channel.